And so as we go through this first one, take a moment and just read through here. So read what the problem's asking, and there are some typos in here, but it says a frog is jumping down to a stream. Get rid of the word from. That would probably be the best thing. Frog is jumping down to a stream bed as a final jump model by the equation. And just change this word distance to height. That's all. All right, once you have that, then go ahead and just take a second, read through it, and then you can. So we don't have to make like a perfect graph here. The graph there, just kind of make a sketch. We can do that. We don't necessarily have to. So for part A, when it says as he jumps, what is his maximum height he reaches from the stream? So if we're looking for a maximum height, what part of our graph are we looking at? We're looking for. How do I know what my answer is going to be? Using that green sheet can help us. What? Right, we're looking for the x value of the vertex. That's what this one's going to be. Which again, you can call that the k value if you'd like. Sorry, the h value if you want. H value or x value of the vertex. Actually, we want the maximum, so we don't want the h value. We want the k value. Okay, we want to know how high you got. Okay, so we're looking for the k value in that case. Either way, we're going to need the vertex. So again, there's a couple ways we can find our vertex. One way is completing the square. So that's what I'm going to do. I'm going to complete the square here to try and find the vertex. So remember, when we have a number that's larger than 1 or not equal to 1, we pull that out as a GCF. So here I have a negative 2 as my a value, so I'm going to pull that out as a GCF. And remember, that means I'm dividing everything by negative 2 to see what I have left inside. So that would give me t squared minus 2t minus 5. You're with me? Pulling out GCF because we're going to complete the square. So now as I go to complete the square for the inside, I have one square here. Again, if you can do this in your head, perfect. Which would be t times t. And I'm dividing the 2 by 1. Sorry, the 2 by 2. So that would be x minus 1, x minus 1. And then we're missing 1 from that. Yes? All right, from there, I can complete the square on the inside, rewriting this. So I have the negative 2 that's going to stay in front. And then inside those brackets, I'm going to put the completing the square part. So it's t minus 1 times t minus 1, or t minus 1 quantity squared. We're missing 1 from that. And going back, we already had minus 5 as our constant at the end. We can combine our like terms, the negative 1, and the negative 5. That would give us minus 6. And then what do we have to do with that negative 2 to get it fully into graphing form? We got to distribute it. So when I distribute that negative 2 to the binomial squared, remember it just goes in front of that binomial squared. And then I have to do the negative 2 times negative 6, which would be positive 12. So this means we would have a vertex at what point then? 1 comma 12. So if we wanted to make a quick sketch, we could. Here's 1, 2, 4, 6, 8, 10, 12. 112, that would be our vertex, which we know that's going to be the highest it gets to. So when we want to know the maximum height is 12 feet. Sorry, inches. I think, does it say inches anywhere? Oh, it doesn't say anything, so we'll say, it does say inches. Okay, that's what I thought. All right, so we need 12 inches. And we're going to do, the T is in seconds, we're going to say. That should be in there. All right, part B then says, at what time does it reach the maximum height? So what part of our equation are we looking in this case? We want to know the time at which it got the max height. Your green sheets if you need to. Looking for the time of the max height, Alex. The h value of our vertex. Good. So we already have that. That would be at 1. So at 1 second, it reaches max height. All right, then it says, what time does he land in the stream? So going back into the ground, the stream is right here at the bottom. This is our stream. We'll make it blue. There's our stream. Woo! All right. That's at a height of 0. So if we want to find the height of 0, that's essentially going to be our x-intercept. So to find our x-intercept, we're plugging 0 in for the whole h of t, that whole left side. And so I could do one of two things. I could put it in for this form, but this form I'd have to pull out a GCF, and then it's not even factorable. So if I pulled out a GCF, you guys don't have to write this down if you want to save space. If I pulled out a GCF, I would have negative 2t minus 5, and we already did that over here. Is there anything that multiplies the negative 5 that adds to negative 2? No. So that means I'd either have to do quadratic formula, which I don't want to do. So what I'm going to do instead of factoring is I'm going to look at the graphing form, okay, this form, instead of the standard form, because I can undo that to solve. So I'm putting 0 into the vertex form version. So negative 2 times t minus 1 squared plus 12. If you put 0 in for h of t for the standard, you'd have to do quadratic formula. And that's not something I like to do a whole lot. So if I'm now trying to solve for t here, since there's no other t's outside of that parenthesis, I can undo this. So PEMDAS backwards. So if I have a plus 12, I undo that first. The minus 12. And then I can undo multiplication. So I'm dividing by negative 2. That gives me positive 6. And then we can undo the square with a square root. Just don't forget, when you get a square root, you need to do plus or minus when you take that square root. So I'm going to have t minus 1 equals plus or minus the square root of 6. And then I would add 1. So I would get t equals the square root of 6 plus 1, and also negative square root of 6 plus 1. But if we think about this for a second, square root of 6 plus 1, will that be a positive number or a negative number? Positive. What's the negative square root of 6 plus 1 going to be? A negative. So the negative square root of 6 plus 1 will be over here somewhere. Positive will be over here. So can I use this one, negative square root of 6 plus 1? No, because that would be 4 times 0. So that one's getting crossed out. And we can say square root of 6 plus 1. And you can use your calculator. you don't have one, get one out, and figure out what roughly that would be equal to. Oh. All right, what's square root of 6 plus 1 equal to? Anyone out there? Square root of 6 plus 1. I just want the decimal version. Let's type square root of 6. Yeah, 3.45, 3.5. Yep. So about 3.5 seconds, about 3.5 seconds in, it would hit the ground. Okay, last thing we want to do then is at what height did he take his jump? So where did he start his jump? How high up this tree or whatever did he take his jump to come back down? So we're basically saying where is it starting on the y-axis? So we're finding the y-intercept for this one, which is going to be where we plug t0 in for the t's. So it'd be negative 2 times 0 squared plus 4 times 0 plus 10. These become zeros, and so we get 10. So that means it started 10 feet, or sorry, 10 inches. I keep saying feet. 10 inches off the ground. So here's this essentially would be what our sketch looks like. The frog is starting at 10 inches, jumps up, reaches a max height of 12, and then lands all the way back down into the stream. Okay. So really, there's not much difference with this than what we were doing last week. It's just now that we have like context to the situation, sometimes it makes it a little harder to figure out what are we trying to find. Are we trying to find the x-intercept or the y-intercept or the vertex? So that's where that green paper is going to come into play to help you out. All right, so try doing number 2. Get us started on number 2, and then we'll kind of see where everyone's at with that. You do not have to go in the same order. Not every problem is going to be the same. Look to see what is given to you, and then look to see what you're trying to answer, and answer it in that order. All right, so for number 1, when it's asking for the initial height, what are you really trying to find when we're trying to find the initial height? The y-intercept. So that's what you're doing for this one. So that is, again, y-intercepts where you're just putting 0 in for the t. So in this case, it's going to start where? At 0. So the height, initial height was 0 feet, which makes sense because you're kicking it off the ground. So then when it's saying how long was the ball in the air, that means you're trying to find the x-intercept then. So this is going to be your x-intercept. So take a moment, try and find your x-intercept. Think about how you might do that. Okay, so remember, x-intercept is where you plug 0 in for your h of t. So it'd be 0 equals negative 1/3 t squared plus 4t. You have a couple of options here. Overall, I'm thinking I want to factor this. Right now, this negative 1/3 is what's kind of throwing me off, though. So what can I multiply this entire equation by to get rid of that negative 1/3? 3 and negative 3. So again, this is probably the easiest way to do it. It's not the only way you can do it, but if I multiply this entire equation by negative 3, it would get rid of that fraction in the front. So that would give me 0. So I'm going to just put the 0 on the right-hand side. Negative 3 times negative 1/3 is positive 1 t squared. Negative 3 times 4 is negative 12t. Now I can look to factor this. What's the first thing we always look for when we factor? Even before perfect squares. 3 letters. GCF. So we gotta look for a GCF. Do we have a GCF in this problem? Yeah, we have a t, right? So if I pull out a t, I get t minus 12. And then I can set the t equal to 0, the t minus 12 equal to 0. And so I end up getting two x-intercepts. One of them is 0, which we already knew about. The other one would be at 12. So that's how long the ball is in the air for 12 seconds. And then C and D say, when does the football reach its max height and what is the max height? So that means we're trying to find the vertex. Now, you could do the vertex by completing the square if you want. However, I have both x-intercepts right now, right? And what do we know about the vertex? It's where in relationship to the x-intercepts? It's in the middle, right? So since I have those x-intercepts, instead of completing the square right now, I'm just going to find the middle of those, and then I can go from there. So again, there's a multiple ways that you can go here. So I'm going to find the average of the x-intercepts, and that would give me 0 plus 12 divided by 2. So 0 plus 12 is 12, divided by 2 is 6. So that's going to be my h value. And since we're talking about a when value, right? When would be time. We know that our answer for letter C, when it reaches its max height, would be 6 seconds. It's going to be the h value for our vertex. This is going to be the h. This is going to be the vertex, and it's the x value for that vertex. And the last one is saying, what is the height of that football at the max? So we know that we just want to find the height when the t is equal to 6. So we can just find, h of 6. So if I put 6 in for the h, what would that give us? 6 squared is 36. 36 divided by 3 is 12, negative 12. So this would be negative 12 here plus 24. So we'd end up with positive 12. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 6, 12. So that's what your football is going to look like. Coming up, coming back down. So again, 6 seconds is when it reaches max height. That highest point is at 12 feet. Okay, so again, it's a lot of it's just getting through the words to try to understand and figure out what you're trying to get to. Now, if you did want to complete the square instead of doing the average, you could. So you don't have to write this down, but if I wanted to complete the square, I absolutely could. Remember, for completing the square, you need to pull out the a as if it was a GCF. So if I put a negative 1/3 out in front, I would divide everything by negative 1/3 then, and I would get t squared. And then this is like a keep change flip because I'm dividing by a fraction, so that'd be minus 12 there. 12t. And then I would have to do my squares. So this would be a t squared, which is t and t, minus 6, minus 6. So we'd be missing 36. So I would have the negative 1/3 in front, and it would become t minus 6 quantity squared minus 36, and we didn't have any extras in there. And when we distribute that negative 1/3 through, we get negative 1/3 t minus 6 quantity squared, and then this would become negative 1/3 times negative 36, which would become positive 12. So again, we get the same vertex, 6, 12. I just thought it'd be easier in this case since I had the x-intercepts to average them. So again, a lot of ways you could do these problems. All right, so you are doing number 3 for homework tonight. 4 we will do in class tomorrow. Okay, just do number 3.